All right, so I just want to give you a few problem-solving tips for proportions. Um, but really, some problem-solving strategies that I've used all through my mathematical and scientific career, and even in my life, I would say. So remember that a proportion is basically an equation where you have a fraction equaling a fraction. So like 2/3 equals 4/6, or x over 5 is equal to 23, because 23 could be 23 over 1. So that's what a proportion is. And I want to talk about three things. So the first thing is just thinking about converting words to mathematical expressions and how we can think about some words. The second is using units to set up proportions and solve problems. Units are really, really valuable for thinking about problem solving, for contextualizing numbers, and really all the applications that we use proportions for in our real life, whether it be, adjusting a recipe, or maybe in a science class, like thinking about a chemical, what do you call that? When you reaction, let's say. They all involve units, teaspoons and milliliters and feet and seconds and all these things, these units that make the numbers make sense to us. And then finally, when solving proportions, I've got just sort of some mathematical truths and tips that are going to help you there. Okay, so let's move to the first one, which is some tips for converting words to mathematical expressions. I'm trying to get this out of the way, but it seems like it's not staying out of the way. So maybe I'll just make it a little bit smaller. There we go. Okay, so here's a few things I'd like to say. Okay, the first is that when you see things like what number or when, these are usually your variable. So you can choose whatever your variable is, but often the variable that we choose to represent something like what number is x. So what number is often x. Another thing we have quite frequently, especially with proportions, is what percent. So that's very similar, except for remember that percent means per 100. So that would be x over 100. So what and when, these words right here are indicating to you that you need a variable, because a variable is, maybe how long as well, but a variable is something we're looking for. So when it says what percent, okay, x over 100, or what number, we would just call x. Sometimes when is that going to happen, we might call t. But when you see these question words, you should be thinking, I bet I need a variable. Okay, so that's one tip there. Question words are indicating that you need a variable. Of, the word of means division. So when you hear, say, 3 of 10, that is saying 3/10, 3 divided by 10, or 4 of 60, that's saying 4 of 60. So the word of often means divide. Okay. When you see the word is, that is an equals sign. So the word is just means equals. And I already kind of touched on percent, but of course, anytime you see percent, you should be thinking some number over 100. That's what we write for, 20% is going to be 20 over 100. 15% is going to be 15 over 100. So this is maybe not the most clear thing. So maybe I'll just add in another another slide here to make sure that it's really clear that basically what we have is when you see, what or when, you should be thinking of that as a variable x. When you see of, you should be thinking divided by something. When you see is, you should be thinking that that's going to be an equal sign. And when you see percent, you should be thinking, oh, you're going to have some number over 100 because it's per 100. Okay, so let's look at an example, which I'm going to type in here as, what number is 30% of 70? Okay, so what number is 30% of 70? So let's apply some of my tips here to see what we can figure out. So what, when, what number? This right here is making me think that I need a variable. So I'm just going to write x up here. What number? That's what I'm looking for. I'm seeing an is right here, right? There's the is, and that is an equals sign. So I'm going to say equals. And then 30%, right? Well, that should be, I think, like a 30 over 100. That's the 30%. And then I've got the of 70. So that is going to be something here that is going to be something like divided by 70 because I saw the of 70. Now, the confusing thing is that it doesn't go exactly in this order. What number is 30% of 70? The number is the thing that's getting divided by 70. So if I were to rewrite this as a mathematical equation, it would be x of 70 equals 30 over 100. And now I've got a proportion. So it's a little bit confusing because the way that we talk doesn't quite track to mathematical equations, but you can see that I've got what number, okay, I'm going to circle with my laser, what number of 70 is 30%? What number is 30% of 70? What number of 70 is 30%? So that's basically what we would translate there. All right, let's try another one. Let's try this one right here. 75 of 23 is what percent? Okay, so again, we've got some numbers. We've got a what percent. So that what is indicating that I'm going to need a variable. So right here, I'm going to need an x. Percent is going to be over 100. So I think what percent is going to be x over 100 is, there's my equal sign right there. And 75 of 23, well, there's my division, right? So I'm going to have like 75 over 23. All right, so let's write that down in something that stays. 75 of 23 is what percent? So that would be the equation that I get, and actually works in a nice order there. 75 of 23 is what percent, or x over 100. Let's try one more, and then we'll move on. Okay. So let's put this as 16 is 25% of what number? Okay, so this one's going to be a little bit out of order as well, but let's use our laser here and see if we can figure it out. So is, there's an equal sign right there. 25% should be 25 over 100. Of, there's going to be some division, and what number is my variable? So is 25%, let's write that first, is 25% equals 25 over 100 is 25%. 16 of what number? 16 over x, that's 16 of what number? So looking at this proportion right here, we would have 16 of x, or what number, is 25%. And that leaves us with our proportion. Okay, so that's the first thing. Just some things that can help you think about translating words to mathematics. What, indicating that you basically have a variable. Of indicating some sort of division. And is indicating that equals sign. Okay, so that should help us out there a little bit, maybe. but a lot of it just comes with practice. Okay, so what about units? So the tip that I want to say here is that units must match across equations and proportions. This I did not really learn or figure out until maybe college sometime. So I really think thinking about this early is going to be really helpful, because eventually I figured it out somehow, and then it just really helped me solve problems. So let me give you an example of what I mean by units must match across equations and proportions. It's kind of obvious, but then also not at all. So here's an example. If you have $20 and that's split between 30 people, okay, then if this is equal to another fraction on the other side of the proportion, let's say X dollars for 50 people, these units right here, dollars per person and dollars per person, have to match. Otherwise, you do not have something that can be equal. So dollars matches dollars, people matches people. These things have to match. Okay. Now, another example might be if you have 13 hydrogen atoms per, say, 200 molecules of something. And then that could be equal to, say, 25 hydrogen atoms per how many molecules? So you could then figure out, well, how many molecules am I going to have? How many molecules, you know, if I have 25 hydrogen? But again, you'll notice hydrogen over molecules, hydrogen atoms over molecules. So we really want to make sure that those units match. Now, there's one case where they don't exactly have to match, and that would be something like this. 20 centimeters, whoopsies. I messed that up. I got to figure out how to, let's see if I can undo that. 20 centimeters divided by 100 centimeters is equal to 30 meters divided by X meters. So the reason that this is okay is because centimeters over centimeters is just 1. Just like 2 over 2 is 1 and 10 over 10 is 1. Meters over meters is just 1. Those units cancel, basically. So we would say that these are, in fact, unitless. So the units still match because these are unitless. We could rewrite this as just 20 over 100 equals 30 over X. So if you have the same units over the same units on both sides, that's okay, because then you have no units. Okay, so units must match across equations and proportions, because proportions are just one type of equation. Super, super valuable skill to have. Okay, let's move on to the last thing, tips for solving proportions. Okay, so tips for solving proportions. So let's say that you have the proportion 13 over X is equal to 20 over 16. Okay, so what we talked about initially is that you can flip this and you can just say then X over 13 is equal to 16 over 20. Then we can say, since X is divided by 13, I can multiply by 13 over 1 on both sides. Then this will give me 13x over 13 is equal to 16 times 13 over 20. So that's fine. And then I would get X is equal to, since 13 divided by 13 is 1, is equal to 16 times 13 divided by 20. Now I could use my calculator to multiply 16 by 13 and then divide by 20, But I can also recognize that these two numbers share factors, right? 16 and 20 are both divisible by 4. So I can divide those by 4 and then simplify things for myself a bit. So I could say x equals 4 times 13 divided by 5, right? Because I basically divided this by 4 and got 4, divided this by 4 and got 5. So as long as I divide by the same thing on both sides of a fraction, it should stay the same. And I think that ends up being 52 fifths. Okay, so this was kind of our original way, OG way for solving proportions right here. And then I just showed you a little trick here to help simplify. But there's also something that you may have heard of, which is called the cross products property of proportions. And that basically says that if you have A over B equals C over D, then A times D must equal C times B. So this is the cross products property of proportions. Cross products property of proportions. Meaning that if you set the cross products equal, you will still have an equality. That's what this is called right here, cross products property of proportions. And so for this example, what we could do is simply say, well, in this case, then 13 times 16, so I'm multiplying these two, has to equal 20 times x. Now I'm multiplying x by 20, so to undo that, I can divide by 20, and I should now have the same thing as I had over there, right? And so I would get the same solution. Okay, so I'm going to show you one example on one more screen, and then we're going to be done with this. So let's see here. Add one over here, go here, put this up here, get rid of that. So let's take this example, which is that x divided by 50 is equal to 27 over 25. So then I'm going to use the cross products property to basically say that x times 25 is equal to 27 times 50. Then I need to divide by 25 so that I can get x by itself. Now I've found x because I know x is equal to something. And then I can say that it's equal to 27 times 50 over 25. Now again, I could try and find 27 times 50, but I don't know what that is in my head. But I could also look at this right here and note that 50 divided by 25 is 2. So with multiplication and division, you can do them in any order, right? It's PEMDAS, but the M and the D come together, and you can actually do division and multiplication in any order. So it could be PEDMAS if we want it to be. So just as a reminder, PEMDAS is fine, but it's actually okay to do PEDMAS if you want. So that's actually kind of a useful thing, that multiplication and division can come in whichever order you want. So we would get x equals 27 times 2. And this again is since 50 divided by 25 equals 2. And then 27 times 2 is 54. So we get 54. So to summarize, I would just say, solving proportions, you can use the cross products property, which is that if you have A over B equals C over D, then you know that A times D is equal to C times B. So that's this product equals this product. And simplify. If you have like 13 times 8 divided by 6, you can divide this by 2 and get 4, divide that by 2 and get 3. And since this is multiplied, we can simplify in that way and then, get make our lives a little bit easier. 4 times 13 is 40 plus 12, 52 divided by 3, is some number. So you can simplify and then make your life a little bit easier. So I think that's it. Going back to the very beginning, hopefully that helped you think a little bit about converting words to mathematical expressions, right? In which we talked about what and when, helping you find a variable, of meaning division, is meaning equal to, and percent being some number over 100. We also talked about units and how they have to match across an equation. So each side of the equation has to have the same units. And then we talked about some tips for solving proportions. So thanks for watching and see you soon. Bye.